sir. Myself Mohchan Molla. My roll number is 34900323027. Department Electronic Communication Engineering. Today I will discuss about pulse code modulation. Definition: a technique by which analog signal get converted into digital form in the order to have signal permission through a digital network is known as pulse code modulation. It is called PCM. PCM signal are basically signal codes, also known as waveform coder. PCM allow the representation of the continuous time message signal as a sequence of linear coded pulses. The binary from permit only two probability states 0 and 1. The major stage involved in PCM is sampling, quantizing and encoding, which will be basic basics of PCM. In pulse code modulation, the analog message signal is first sampled and the amplitude of the sample is approximated to the nearest set of quantization level. This allows the representation of time and amplitude in a discrete manner, thereby generating a discrete signal. Block diagram: input signal, low pass signal, input signal, low pass filter, sampler, quantizer, then encoder, then channel. After channel, quantizer, then decoder, then reconstruction filter. At last, output signal. PCM transmitter, message signal, low pass filter with FC equal FM, sampler, Q level quantizer, binary encoder. Then output, low pass filter. Here the message signal, which is the continuous time from, is allowed to pass through a low pass filter. This low pass filter, whose cutoff frequency is FM, eliminates the high frequency component of the signal and passes only the frequency component that lie below FM. Sampler. The output of the low-pass filter is then led to a sampler where the analog input signal is sampled at regular interval. The sampling of the signal is done at the rate of fs. This sampling frequency is so selected that is must follow the sampling theorem that is expressed as fs greater than equal to fm. The output of the sampler is a signal that is discrete time continuous amplitude signal denoted as NTS, which is nothing but a PAM signal. Quantizer. A quantizer is a unit around of each sample to nearest discrete level. The sampler provides a continuous range signal and hence still a analog ones. The quantizer performs the approximation of each sample, thus assigning it is a particular discrete level, as it basically round off the value to the certain level. This is so some variation by the actual around. Thus, we can say quantizing a signal introduce some distortion or noise into it. This is known as quantization error. Here, samples for analog signal, then quantization of sample for discrete time. Each of line is a sample number of samples. Encoder and encoder perform the conversion of the quantized signal into binary code. This unit generates a digitally encoded signal, which is a sequence of binary pulses that act the modulated output. As it is a binary encoder, thus generates a binary coded sequence that is transmitted through the path. Transmission path in a PCM system. A PCM system has a better control over signal distortion introduced during transmission through the channel than other systems. PCM achieve low signal distortion by employing regenerative receivers along the transmission path. The channel introduce distortion in the signal during a transmission. This distortion is eliminated by regenerative in the order to provide a distortion-less PCM signal, resultantly enhancing the transmission ability of the system. Block diagram of regenerative repeaters. Distorted PCM wave amplitude equalizer, decision-making device, timing circuit, regenerated PCM waves. The PCM signal, when provided to the regenerative repeater, the equalizer circuit at the beginning performs the S-ping of the distorted signal. At the same time, timing circuit regenerates a pulse or trend that is a derivatives of input PCM pulse. This pulse trend is then utilized by the decision-making device in order to samples the PCM pulse. This SNR can be achieved in the way the decision-making device generates the distortionless PCM wave. PCM receiver, PCM signal noise regenerator, DAC sampler, low pass filter with FC minus equal FM. Original output regenerator. A regenerative repeater is placed at the receiving end also as to have an extra PCM transmitted signal. Hence, also the regenerator work in a similar manner as the when the employ in the transmission path. It eliminates the channel, introduces noise and receives the pulse. DA and sampler, digital to analog converter, perform the conversion of digital signal again into its analog form by making use of the sampler. As the actual message signal was analog, thus at the receiver and there is necessary to again convert it into original from low pass filter. The sampler generates analog signal, but that is not the original message signal. Thus, output of the sampler is lead to the low pass filter having the cutoff frequency FM. This is the sometimes termed as the reconstruction filter that produced the original message signal. Transmission bandwidth of pulse code modulation. The transmission bandwidth of a PCM system is associated with number of bits per samples. If the number of bits per sample increase, the bandwidth also increase. In order to have a good approximation on a large number of levels must have use, but that will have lead to a large bandwidth requirement. Q equal to the power n. Transmission bandwidth is half the significant rate, hence bandwidth is greater than equal r by 2. PCM of speed signal. Most of significant or spectral component of speed signal are contained in the range 300 to 3400 Hz. Nyquist rate 2 into 10 to the 2 into 3400 equal 6.8 kilohertz. Practical sampling rate fs equal 8 kilohertz. Number of quantization level 256. Number of bits per sample 8. Quantization. By quantizing the pulse, original signal is only approximated. Quantization discretize the amplitude of continuous PAM signal. Since the original signal can have an infinite number of signal levels, the quantizing process will produce error called quantizing error or quantizing noise. Here, two type of quantization are error. One is mid-rate, second is mid-rise quantization. What is quantization? Quantization is a non-linear linear transformation which map eliminate elements from a continuous set to a finite set. It is also the second step required by AD conversion. Analog signal samples quantize digital signal to quantization ratio SQNR. The signal to quantization noise of the quantizer is defined as S by N equal signal power by noise power. Each type of signal is input x of t is known, then it is the possible to calculate signal power. Then noise power is given as noise power equal to uh, V noise square bar by R. Here V noise square by R is the mean square value of noise voltage. Since noise is defined by random variable L, random variable epsilon and PDF f of epsilon, it is mean square value is given. Mean square value E epsilon square bar. When load resistance R equal to 1 ohm, then the noise power is normalized. Noise power equal to del square by 12. The number of bits V and quantization level is Q. Then they are related as Q equal 2 to the power V. Del equal to 2x max by Q equal 2x max by 2 to the power V. S by N equal P by del square by 12 equal P by 2 2x max by 2 to the power V whole square into 1 by 12 equal 3P into 2 to the power 2V by x max square. Signal to quantization noise ratio will be S by N equal 3 P into 2 to the power 2 p when n x max equal to 1. If destination signal power P is normalized P less than equal 1, then S by N less than equal 3 into 2 to the power 2 p. The signal to noise ratio is decibel. S by N and decibel equal to 10 log 10 S by N equal 10 log 10 C into 2 to the power 2V equal 4.8 plus 6V decibel. Thank you.